Impedance matching modules, basic information. Generator and impedance matching module sets. Main parameters. Application: dielectric welding, dielectric heating, plasma processing, metallurgy, medical, research, light-emitting plasma, diathermy. Control options: optical toslink connected with generator. Communication module optional for independent operation. Opto-isolated simple logic inputs-outputs, RS-232, RS-485. Main advantages: high-speed solid-state topology, simplified gamma LC topology, configurable SWR levels, dynamic change in the size of LC steps, various options for impedance matching range. Excellent control and data acquisition. Classic solution: variable vacuum capacitor, mainly mechanical design, many moving parts, low regulation speed, many components prone to wear, advanced control is required. High-speed solid-state topology. Solid-state switchable capacitors and inductors. High speed. Long lift time. Direct switch to any position without whole range crossing. Now moving parts. High-speed solid-state topology. HF industrial technology impedance matching systems can switch LC level to start position in 0.1 second. Regulated coil classic solutions. In many applications, it is necessary to use circuits containing inductances to match the impedance. Due to the difficulties in manufacturing regulated coils with small inductances, equivalent systems containing a fixed inductor and an adjustable capacitor are often used. Regulated coil classic solutions. Classic topology causes highly nonlinear regula tie-in. This can degrade resolution or fine-tuning in some ranges and reduce regulation speed in others. In addition, it introduces a resonant circuit into the system, which unnecessarily increases the voltage. Regulated coil simplified gamma LC topology. In HF industrial technology solution inductor is only inductor. As a result, the voltages in the system can be lowered. Additionally, the characteristic of reactance versus inductor level is linear and not inverted. Configurable SWR levels. It is possible to select the SWR level for calibration and adjustment during process. There are 4 settings. In most cases, fine-tuning can be used. Only in the case of loads with a very narrow characteristic may be necessary to apply a less precise regulation. Dynamic change in the size of LC steps. As standard, only one of the control elements is switched one level at a time. This is the proper speed of regulation in most situations. This ensures very high stability of the control process. However, in dynamic processes, such a control method may not ensure the maintenance of the required SWR level. For this reason, there are operating modes that allow switching L or C by several levels in one step. The number of levels to be switched is determined by an algorithm based on the deviation of the value of the current load and the value of the current load impedance level from the nominal impedance of the system, i.e. from 50 ohm. The greater the deviation, the more levels L or C can be changed. Dynamic change in the size of LC steps. There are 4 settings. 1111, basic, only one level L or C is always switched. 1123, for very small and small deviations of impedance only one level L or C is switched, for average deviations 2 levels are switched. For large deviations of impedance values 3 levels are switched in one step. 1, 2, 3, 4, LC levels can be changed by 1, 2, 3 or 4 levels in one step depending on the deviation of the impedance value. 1, 2, 4, 8 C levels can be changed by 1, 2, 4 or 8 levels in one step depending on the deviation of the impedance value. Dynamic change in the size of LC steps. Differences in SWR bump during very fast process. Visible significant increase in SWR in standard 1111 mode. Visible change of LC levels by one position in one step. Same process, big reduction in SWR bump in 1, 2, 3, 4 mode. Visible change of LC levels by 4 positions in one step. Various options for impedance matching range. Approximate load impedance ranges supported by each type of impedance matching. The span of the range is similar for all types within a given model. The differences in the selected area result mainly from the nonlinearity of the Smith chart. Data acquisition. Each impedance matching module has measurement of input forward and reflected power, SWR, and output complex impedance. Data is collected every 100 milliseconds and is available for external systems. In addition, data relating to internal supply voltages and temperatures are available. Process control analysis of LC level. During the process, the load impedance changes. The IM2 controller regulates the LC, trying to maintain the correct SWR level. These changes take place every 100 milliseconds. By analyzing changes in LC levels and comparing them with the pattern, it is possible to quickly determine if there were no errors during the process. In addition, by analyzing the data on the energy supplied to the load, the process can be evaluated with great accuracy. Disclaimer. All values are typical under certain conditions. Different fixtures can affect its circuit performance. All information contained in the presentation is tentative. For more details, please contact HF Industrial Technology. Voltages and currents, especially high ones, can be very dangerous for humans and other living creatures. High-frequency voltages and currents can generate high-intensity electric and/or magnetic fields which can be dangerous for humans and other living creatures.